Hello, everybody. My name is Matthew Rocklin. I work for Continuum. I work on this project called Blaze. There's been a lot of hype about Blaze. I'm just going to sort of talk very basically about how it works. And again, a little bit after this, Phil's going to talk about actually using it and getting some numbers out. Okay. So very briefly, so the too long didn't read on this is that Blaze is an extensible interface for data analytics. So it helps you do queries like NumPy and Pandas queries. But it doesn't run NumPy and Pandas, it runs other systems. It runs Postgres, or it runs Mongo, or it runs out-of-core things. So it's an attempt to sort of bring the Python ecosystem outside of in-memory computing. Okay. It does that not through building a new database, rather by letting people use their sort of familiar interface to access existing technologies like Spark, or Impala, or Mongo, or Postgres, etc. Okay. Motivation. This community is really based around tools that have been based around the NumPy and Pandas libraries. These libraries are sort of foundations on which lots of our tool sets exist. Scikit-learn and matplotlib, both talk NumPy arrays and Pandas data frames. And that common interface, those data structures, have really allowed all of us to work on many different things and use lots of different tools and just sort of pick up tools at random and know that they'll work together. Okay. But NumPy and Pandas is pretty much limited to in-memory computing. And that's sort of a limitation. As sort of data sets get bigger, as we have many more cores to use, that becomes challenging. And so if we sort of want to grow the ecosystem outside of that space, we're sort of thrown into this Wild West situation where you've got one of 10, 20 different things you could use, and you're not sure what to use. And even if you sort of find one or choose one, you have a lot of learning to do. There's a lot of new things to play with. Okay. So it's sort of challenging to branch out outside of in-memory computation. And that's sort of the thing that Blaze is trying to approach. Okay. Blaze is just a user interface, so it's just sort of something you type at. And it's also something like a compiler. It is something that sort of takes the thing that you type and translates it into something that some other system uses, like SQL or Mongo queries. Okay. It is for analytic processing, not for transaction processing. So things like Pandas or NumPy, not things like Redis, if you're familiar with that. Okay. It does not try to replace databases, nor does it try to replace Pandas. It's just complementing them with interface. Okay, so what I'm going to try to do here, so I usually give talks about this topic. I have lots of slides, and the slides are sort of boring because it just looks like Pandas all the time. You're like, oh, well, I already do that, so why do I care? Right, so I'm going to try something new, something scary for me. I'm going to try actually interacting with Blaze live, and so please be kind. Okay, so I'm looking at this thing called data. Okay, data, I'm going to move this a little bit. Hopefully people still hear me. If that doesn't work, let me know. Yeah. Okay, so I'm going to wrap Blaze around a single Python integer. Okay, so here's that integer wrapped with Blaze. This is a Blaze thing, and that Blaze thing looks like any other integer. Right? But if I actually look at that thing as a string, we'll see that Blaze has actually been creating some expression for me. So that's been typing things, it's actually been sort of recording what I've been typing. And as I sort of rep it to the screen, as I print it to the screen, it actually does some work. Okay, so there's a separation between what we're typing and what actually gets computed. Okay. As a slightly more interesting example, whoops. Let's play with a, sort of a tabular-like data set. And we'll give it some names to play with. And again, this looks exactly like Pandas. And we can do exactly like Pandas things. Second. Exactly like Pandas things. Here we'll find all of the accounts with negative balances. We'll get out their names. Oh dear. Thank you for telling me. Okay, looks like Pandas. Let's actually go one further and just have Blaze drive a Pandas data frame directly. And again, exact same experience. So whether or not Blaze was driving Pandas or Python lists, we saw no difference. Now, Blaze wasn't doing work. It was telling Pandas or it was telling Python to do work. In the first case, it was writing for loops, and Python was executing those for loops. In the second case, it was calling Pandas functions, and Pandas was doing the work. So we saw the same experience, same user experience, with presumably different performance guarantees. Presumably Pandas was faster. We say, well, I already know Python, I already know Pandas, so why would I ever use Blaze? The answer is if you want to go outside of these two systems. So for example, if we were to create a SQL Alchemy table, SQL Alchemy is a project that translates sort of Python code into SQL code across many different dialects, Postgres, MySQL, Impala, Hive, whatever, other things. We can have Blaze play with that too, right? And so this object, looks and feels a lot like a data frame. So Blaze has gone into this table, checked out the metadata, and has given you back this Python proxy object that you can interact with as though you were playing with a Pandas data frame. Okay. And so let's do our same computation. This is a little bit different because it's a raw thing, so I'm going to call this thing. And so what Blaze gave me back was a SQL Alchemy select statement. So if I give Blaze a SQL Alchemy thing, it gives me back a SQL Alchemy thing. If I give it a Pandas thing, it gives me back a Pandas thing. If I give it a Python thing, it gives me back a Python iterator. Okay. And we can sort of use SQL Alchemy then to print out the SQL that's relevant there. Okay. So Blaze is doing this work. SQL Alchemy is generating the SQL, because that's great, because SQL Alchemy is great at generating SQL. Blaze is just driving SQL Alchemy. So let's do a more fun example. There's this Laman baseball data set. So there's a database. I'm pointing Blaze at a SQLite database. Okay. And we can sort of look at this whole database and see the tables that are in there. There's this teams table. I'm going to want more space here. There's this teams table. There's this salaries table. Okay. And we're actually we're going into the database and doing work there and bringing results back. Let's join these two. And again, this join is happening in SQLite. It's not happening in Pandas. We're not pulling data from the database until we absolutely need to. Okay. And let's compute. Let's do this. Let's compute. I want to do by joined. So I'm going to do a split apply combine operation. I'm going to group by the team name and the year. So let's group by year ID and name. And I want to find the average salary. That'll be joined .salary.me. Okay. So this is slightly different syntax from Pandas. Split apply combine syntax has been changed a little bit, but it still sort of gives you the same feel. Okay. And now here we're doing a split apply combine operation. It's happening in SQLite. We're getting results back. We've only actually fetched enough results to print something to the screen, but we could, we can push this into foo.txt. Oh dear, what did I do wrong? Okay. So actually, the fact that I got an error is interesting, because I got an error instantly. Blaze is able to tell that I did something wrong as I was typing the thing. It didn't have to go out to the back end and compute and say, oh, the back end said, oh, something wrong happened. Blaze is able, because it has this proxy object, can sort of tell me immediately that I've done something wrong. Okay, so let's look at that file. Okay, so here's my result. Okay, so what I've done is I've operated in a Pandas-like way, but I've driven a foreign execution environment, SQLite in this case. But it still felt familiar. So people who like Pandas can have that same experience. Okay. The nice thing about SQLite, so the nice thing about SQL Alchemy is once you touch SQLite, you've also touched Postgres and MySQL and Oracle and other things. So my friend Ben, who's great, put up this little Impala cluster on EC2, hopefully. There we go. So we're actually going out to EC2. We're going out to EC2. We're talking to an Impala database. And it'll take a second. We can see what's there. And we see there's this trip data thing there. And this is the New York City taxi cab data set. The monorail people talked about this earlier today. And here, sitting on some EC2 box, or I think this is a very small cluster of 4 boxes or something, but this could be an arbitrarily large cluster. And again, we can interact with it in a very smooth way. We've got all this autocomplete stuff. It sort of feels very natural. And so we'll do a little computation, x.shiftData.medallion, and we'll find let me just have this somewhere. Yeah, so we'll find the total passengers, and we'll sort by the passenger count. Okay, and it's gonna take a little bit. So we'll go back over here. I want to emphasize some main points. Blaze is not pulling data into memory. This work is happening elsewhere on EC2, but we still have the same sort of nice Pandas-like experience. Blaze can drive a variety of things through SQL Alchemy. It can drive all the sort of SQL technologies. It can do PySpark relatively robustly, NumPy and Pandas-like technologies, MongoDB, other things like that. Okay. While that's happening, let's go over here. So I want to so that's sort of the first part of the talk is that's what Blaze is. It's an interface that you can use that feels natural, that drives foreign technologies. Okay. That's sort of, in a nutshell, that's what it is. And I sort of want to go a little bit deeper in a second. Before that happens, I want to sort of motivate something. So most of the projects that we like couple a high-level interface, something that's sort of nice to use, with a low-level computational engine, something that's very fast. Okay, NumPy and Pandas both have this feature. There's this blue part, which is this Python code that we like interacting with, and there's this white part that runs fast. And that combination is really nice. But as we said, to sort of go outside of that world, we sort of have to get this sort of wealth of things to choose from, and that's challenging. Okay. So you might choose SQL, which has sort of one single interface, but many different implementations. You sort of go to the NoSQL land, with sort of lots of different interfaces for every different thing. You can go to sort of the high-performance computing land with very little interface, right, but very high performance. There's things like Hadoop and Spark. Hadoop and Spark, I think, is a nice example here. So when you choose a technology, you choose it both based on performance guarantees and based on the usability. Do I know this technology? Can I read the tutorial well? And we choose those technologies based on both of them, when maybe we shouldn't. It'd be sort of unfortunate that we sort of choose, we have to sort of make both choices at the same time. Spark is a good example because Spark sort of sells itself as this in-memory Hadoop alternative, as well as much faster at certain class of algorithms. Most people that I've talked to who use Spark use it because it is so much easier to use than Hadoop. PySpark in particular. One message is try out PySpark. It's actually really usable. You can also use PySpark through Blaze, but it's also good on its own. All these technologies are good on their own. Okay. So Blaze is just an interface. There's no white part. It's just blue. And Blaze sort of sits at the center of the Python ecosystem, using various Python technologies to access all these other technologies. So for example, for SQL, we use SQL Alchemy. For Mongo, we use PyMongo. For Spark, we use PySpark. So Blaze is really a customer of all the other tools people have built, and a sort of one cohesive view onto them. Okay. So I'm going to switch from that sort of high-level Blaze. I'm going to switch to a detailed topic. In the interim, is there time for maybe one question, so we can sort of swap things in and out? Does it work? So the question is, does this work with Amazon Redshift? Or more generally, does this work with Foo? With Foo being some database that I like, right? So the answer is two answers. One, does Amazon Redshift have a SQL Alchemy dialect? It might, and if so, the answer is yes. Many things work with SQL Alchemy. Databases that are sort of relationable-like, or at least provide some SQL-like interface, can often be made to work with Blaze if they can be made to work with SQL Alchemy. Making SQL Alchemy dialects is relatively cheap. For example, the Impala thing was done by Uri Laserson at Cloudera in, I think, a couple days. We had a Blaze issue oh, we should make a SQL Alchemy dialect. Uri came by, made the dialect, and the next day we had Blaze interactions. So generally speaking, making Blaze connections to other databases is very cheap. And if we have time, I'll talk about how that's done. You might think that making Blaze interpreters from Blaze to other databases would be an expensive, hellish process. And in some cases, indeed, it is. But it's sort of designed to be highly extensible. You can make that thing without touching most other parts of Blaze. Okay, thank you for the question. Okay, so I am up at 11:55. Is that accurate? Oh, sorry, I'm from California. 55 past the hour. Okay, I think I have 12 minutes. So I want to quickly talk about high-level thinking and low-level computation. And this will feed in a little bit into what Phil's going to talk about. Before I talk about that with Blaze, I want to use SymPy, which is a project dear to my heart. SymPy is another project that sort of does math. It's like Mathematica. And in SymPy, you can write expressions in Python, and they become mathematical things. They're just Python objects that represent math. Okay? We can make, complex things if we want. It goes much more complex than this. And the nice thing about SymPy is you can also sort of think of things at a high level, and then, I'm losing the screen. After you've thought about things at a high level, you can generate numeric code. That is, you can sort of switch back down to low-level computation. So let's put this into an expression. So for example, SymPy knows how to emit C code. Right? So you can sort of copy and paste this into a function, or you can have various things write NumPy ufuncs for you. And there's no reason to stop at just C. You can also generate Fortran code. Or if you're particularly masochistic, you can generate JavaScript. Or, I actually really like this one. This one's very nice for writing papers. Yeah, see, yeah. And so we can sort of think at a high level and operate at a low level, right? We don't have to choose one or the other. And particularly this is nice because we can actually do some non-trivial thinking at the high level. So, this is really, SymPy can do a lot of things, but I'm doing very simple things like derivatives, right, or second derivatives. And we can combine that high-level thinking with our low-level code generation. Okay, and even more so, we can, this expression looks like it might be able to be simplified a little bit. So SymPy has this simplify function, and indeed it can. And so by thinking both at a high level and at a low level, we're able to write more efficient code. We're able to think very sort of mathematically about our problems. We're able to generate high-performance code better than maybe a human could even sometimes. Okay. So I want to do the same thing with Blaze. I want to think about data algorithms. So Blaze is just like SymPy, but rather than doing calculus and trigonometry, it does linear algebra and relational algebra. So we can think about those things too. A lot of the optimizations that you would find in a traditional SQL system, some of those you can also find inside of Blaze. We can insert projections, we can remove unused things. It's nice. Okay. Let's see. So I don't have time to do this in an interpreter, but maybe. Nope, that's not the right one. There we go. Oh, by the way, just as we're doing this, if you go to blaze.py.org and you go to presentations about Blaze, you will find these slides as well as notebooks, much, much cleaner notebooks than what I've been doing here in a console, but everything's there for you with pros. So everything you can do in your notebook right now if I'm going too fast. Just to demonstrate that, I will just go back to my slides. Okay. So in Blaze expressions, we can, let's get rid of that. So again, we can write these sort of very abstract expressions using Blaze without any data attached. There's actually no data present. We're actually just thinking about computations. Right? We can sort of reason about the shape of things that we have, the data types and everything. That allows Blaze to be very interactive with you without touching the foreign data. Okay. And then, if I have a bunch of different data types, a PySpark instance is spinning up. I'll give you a second. So we have the same data in a list, a data frame, and a Spark RDD. If you know Spark, you know what that is. If you don't worry about it. It's a thing. And so we're going to take the exact same expression, this sort of deadbeats computation, finding everyone with a negative balance, and we're going to compute it against a list, a data frame, and a Spark RDD. And what we get back is a Python thing, a Pandas thing, and an RDD thing, a Spark thing. So here we've explicitly separated out the intent of what the user wanted, that they communicated with us to an expression, this sort of abstract thing, with the data. The data is completely separate. Normally, users don't do this. You should not go home and use this code. This is what happens internally. But I want to show you how explicitly separated these two things are. Okay? And we can just sort of make Spark actually do work. I think we type in collect here. Go Spark, go. Okay. Okay. So in a couple minutes, I want to show you, so that's sort of an idea, the sort of basic idea there, is that Blaze separates out your expressions, your intent, from your computation. By making that separation, we're able to do lots of nice things. We're able to focus on UI separately from focusing on data. Right? When people are making NumPy, making Pandas, they're usually thinking about, they're very smart guys thinking about like exactly how these algorithms work. They're also forced to simultaneously think about how users want to interact with their code. Now they're also very good at that too, but it's sort of nice to think about one separately from the other. Okay. So Blaze allows that to happen. For people, sort of this is, if you wanted to extend Blaze, this is how we organize our code. So what you're seeing here is 3 functions that all compute the expression head, so give me the first 10 things, the first 5 things, the first 2 things, on one particular kind of data. In the first case is how we compute head on the Python iterator. We use the PyTools function take. In the second case, oh, wait, no, that's first case is Pandas, second case is Python, third case it's Spark. And so Blaze is written in this way. There's lots of little small functions. They're all collected together. And whenever I run into, I want to sort this Spark RDD. Say the sort by name. It goes and finds the right function, and this function runs on the data that I had. So to sort of answer your question, this is how we sort of extend Blaze to new things. And this separation makes it very easy to do that. So spinning up a new backend, if Hadoop 2 comes out tomorrow, it takes us on the order of a week, not on the order of months. So you've seen lots of projects that come out and said like, oh, we've got Pandas-like things on Spark, or we've got SQL running on CSV files. There's all these sort of pairwise things. And Blaze tries to handle all of them sort of. It makes a framework to make building those things more easy. Okay. Blaze also does n-dimensional things. I'm going to skip that. Blaze is a language that can help you interact with many tools. I don't claim that you should learn exactly this language and only this language. I don't claim that it supports all tools. But yes, you're right that Blaze attempts, in sort of the grand scheme, to be one interface for lots of analytic processing systems. So yeah, you can use Blaze and connect to MongoDB trivially. Who knows how to use Mongo? Oh, that's actually more than I thought. That's great. Here, I'm connecting to a GitHub. There's a mirror of GitHub hosted in the Netherlands that is on a MongoDB, Mongo database. I think I'm connected over there. Let's make sure. Let's try that again. This does work, I promise. There's connection issues. I'm contacting across the continent. Anyway, okay, I'm out of time. So, okay, quickly? Yeah, very quickly. So let's talk about designing algorithms abstractly, away from data sets. So in particular, sort of going towards the goal of sort of a parallel out-of-core NumPy or Pandas data frame. So I have a 10 gigabyte file, I have 4 gigabytes of memory. How do I compute on that? So we're going to show how you could use Pandas and some out-of-core structure like HDFS or bcalls to do that work. So imagine I have 1 trillion integers in a NumPy array. I want to find the biggest one. How do I do that? Any suggestions? Right. So one solution is just iterate over the array and just compute maxes as you go. Okay. So that'll happen in Python speed. So that's exactly a totally usable solution that you can do right now in your interpreter. That'll also be somewhat slow though, because we have to use Python. Any other solutions? Divide and conquer. So I can split the array into lots of different pieces, compute the max of each piece, and then sort of take all those little maxes and compute the max of those pieces. Right. Right. So that's sort of a chunking solution. Right. So here, that's the solution I've chosen. And Blaze knows how to do that. Blaze can actually take an abstract computation, max, and tell you how to compute that thing on lots of pieces and then together. So we do the same thing. Let's blow this up a little bit. We can do the same thing with sum. It's actually the exact same algorithm. Sum all of the individual chunks, then add all those things together. It gets more complicated if you do something like count. You know, count the number of non-null elements. Well, there's 900,000 in this chunk, and there's 800,000 over here, so there's 700,000 over here. I'm going to add all those numbers together. So I need to count on each chunk, and then sum the result. Okay, so it gets a little more complicated. Let's say we do the mean. If the chunks are not equal size, we need to sum each chunk and find the count of each chunk. And at the end, we need to sum the sums and sum the counts and then divide. Okay. So Blaze is able to do all these things in the abstract, right? Here's a split, apply, combine operation, just a number of occurrences of something. So Blaze is able to do actually a fairly broad set of things in this chunked way. Here's an n-dimensional reduction. So I've got a 10,000 by 10,000 by 10,000 array of x, y coordinate pairs. I want to sum the x and y points and find the variance, and the result is there. So Blaze is able to do, I mean, you should not understand this quickly, but the idea here is that Blaze can think about these things in the abstract, and then we can use NumPy or Pandas, things that Blaze knows how to deal with already in memory, and we can sort of use them sort of twice. So by using NumPy and Pandas as in-memory containers, and using Blaze to think, to figure out what operations should be done, we can build out-of-core parallel backends. Phil, in about 5 minutes, is going to talk about this and hopefully do a demo. Is that right, Phil? Can you do a little interpreter thing? Yeah. We're trying to move data to my computer today, and it's taking way longer to move the data than it is just to compute on it, which is another problem. Okay. So Blaze is an abstract system that does sort of two things for you. For users, it helps you use foreign technologies. So that's the first half of the talk. A lot of people in the room are probably just interested in that. Right? You can use Blaze to access Impala or access Spark, and it'll feel like Pandas. That's use case number one. For developers, Blaze is actually a really nice place to start building other tools. I can use Pandas in HDFS to build out-of-core Pandas in about 100 or 200 lines of code. And so you'll see Phil have some numbers on that. That'll be fun. So sort of two use cases. One sort of the novice use case, one the expert use case. Blaze in general, I think I have to finish up. So Blaze is sort of this general abstract system. It helps you use other things. It also sort of sits at the center of the ecosystem, so it's a good place for sort of further experimentation. Further information can be found at blaze.python.org. You can install it with Conda, and you can also just talk to us. Okay, thank you guys.